In this series of videos, we've been doing examples about correlation and regression, and I just want to do a few more. So in this video, we're going to do problem number 23, again from our textbook, Elementary Statistics, in its 14th edition by Mario Triola. In problem number 23 here, we're given foot lengths in millimeters and heights in millimeters of males, and that data is available in the back of our textbook. This is a sample from that data. Find the best predicted height of a male with a foot length of 273 millimeters. So we're asked to predict a height based on a foot length of 273 millimeters. And then we're going to compare that to an actual known result that's not actually one of the data points in this sample. So we'll wait to do that in a moment. For now, I need to see if there's a significant linear relationship, so I'm going to head to my TI-84 and enter in the data. So I'm going to press enter, go into edit, and I'm going to clear out these lists by hitting clear and then enter, clear and then enter. All right, I'm going to get my data in here. The foot lengths are going into L1 where my X's go. And in a moment, I'll enter the heights into L2. And again, when I finish this, I probably should go through and proofread and make sure I have not made a mistake. All right, I've got my data entered in. We should very quickly just make sure I've entered it in without any mistakes. All right, and now we're ready to find our R value and maybe look at a regression equation. So I'm going to hit stat again, go over to calc, and I'm going to choose that 8th option. All right, I have data in L1 and L2, and again, we don't really need to type that in unless the data is not in L1 and L2. I'm going to go and press enter. Get an R value of 0.857. That's a very large R value. Not quite as nice as the last one we saw in problem 17, but still quite large. Let's see, I have 1, 2, 3, 4, 5, 6, 7, 8 pairs of data. So again, I come to that row in my table. And again, I'm in a situation where there's a significant linear relationship if I'm looking in the second column with an alpha of 0.05. And again, there's also a significant linear relationship even if I have this higher standard, an alpha of 0.01. So regardless of a significance level, there is a significant linear relationship. So we will get to use our regression equation to make predictions. Looking at our calculators, I see the regression equation is 350.27 plus 5.208x. There's my nice happy regression equation. All right, my x's, going back to the original data, were the foot lengths and my y's are heights. So I'm asked to predict a height based on this foot length. So I'm going to substitute that in for x. I'm use my graphing calculator to help us out here. I get 1,772.1. And those are in millimeters. Units are always important. So the predicted height for a foot length of 273 millimeters is about 1,772 millimeters. I'm going to leave the 0.1 off here. I don't think it's going to contribute anything to our conclusion, just thinking about what millimeters are and how small of a unit of distance that is, well, we're told in the problem that the actual height at that data value would be 1776, that in the sample there actually is an actual height of 1776, and this is really close. So, meaning to me that this is doing a good job, that since there is a significant linear relationship, that this is doing a very good job of making that prediction.